In order to prepare for the next unit in CSC 120 and get us ready for Lab 4, we need to discuss several concepts. So this lecture set is going to talk about data types, arithmetic, and text output in Java programs. Okay, so we know that we have properties that can be part of our objects. Think of the boats and the smiley suns and the lollipop trees, where we had the integer values for the anchor points, the anchor x and anchor y. So the properties or the data can be of several types, and so these are the main types. There are more than these, but these are the ones we would be using at the beginning of the semester. Okay, so we have the integer data type. Now you can either say capital I integer or small int. Either one will work. They're kind of interchangeable. And what we mean by this is a number that can be used in calculation but does not have a decimal part. So it's a positive or negative whole number or zero. Okay. If you want a decimal number, then you use what's called double. It's short for double precision value. So double can either be capitalized or not. And this is a number that has digits to the left and the right of a decimal point. Okay. It's sometimes convenient to represent a value that can be the answer to a yes, no, or a true, false question. Okay, and that data type is called Boolean. That's a funny name, but it's in honor of the founder of mathematical logic, George Boole. Boolean, either capitalized or not, is a special. You can have a data type or a value that is either true or false, only one of two possible values. Okay, as far as text information, there's two data types that we can use for letters and digits and punctuation. If you have only one character, a single letter, digit, or punctuation symbol, then we call that a character value or property. And so it's either the full word character with a capital C, or you can use the abbreviation CHAR. And finally, most of the time we will want to work with text strings. So this is collections of lots of characters. You can even have what's called an empty string, which has 0 characters. So 0 or more characters together as one value is what we call a string. It's short for text string. Okay, and that one you have to capitalize. So those are the data types that we'll see in going forward in the course here. So here's some examples of various data types. For integers, if you want to write down the value, it's just a number with no quotes around it, and it can start with a minus sign. Okay, so 45, 0, minus 178, those are all integer constants. For double precision values, you have a decimal point, and it could start with a minus and no quotes around the number. So 3.2, 0.125, minus 50.5, 43.0. Okay, even though that's got no decimal part to it, it's represented as a double precision because of the 0.0. Boolean, a Boolean piece of data is just the word true or false with no quotes around it. Okay. For characters, you have a single letter, digit, or punctuation symbol, something you could type on the keyboard, surrounded by apostrophes or single quotes. Okay, so we have each of these would be examples of characters. Even this with the quote or apostrophe, space, apostrophe, that would be the way to get a single space. And then strings use double quotes. So apostrophes for character and regular quotes, double quotes for strings. 0 or more characters surrounded by double quotes. And the characters that you can have punctuation, you can have spaces, letters, and even numbers can be part of. Like this would be somebody's address, but that would be a text string. Okay. Now, properties that we use in a program can have any of these data types. So we can declare, I've declared 4 properties here in this example. An integer called quantity, 2 doubles, price per item and total cost, and a string called item description. All right. And then in the MU panel, we could use this assignment statement to store specific values in the properties. Now, the data types must match. So if I have an integer property quantity, I'm going to store the integer constant 20 in that variable. Okay, so that you have to match. And the destination goes on the left here. So price per item 2.50. Item description, it's a string, so I have to have quotes around the Twizzlers. And then you can also perform calculations. I'm going to talk about what this asterisk means, but you can perform calculations and store the result in a property. Okay, so this assignment statement that you see with this equal sign, it has a particular direction that it's going to use. So it's used to store a value in a variable or a property, and the destination goes on the left-hand side of the assignment statement. So on the right-hand side is some expression. We work out the value of the expression and then store that in the memory location, either the variable or the property on the left-hand side. Okay. Now, what happens when you encounter an assignment statement is the first thing that happens is if the expression involves a calculation or even is just the name of a variable or a property, we evaluate that right-hand side. We look up or we work out the value of that problem so that we know what we have a particular value that we're going to work with, and then that is stored in the destination that's on the left-hand side. Okay, so you always work out the right-hand side first and then store the result in the left-hand side. And the left-hand side must be a variable or a property. Okay? And the expression on the right-hand side could be a constant, it could be a variable, or it could be a calculation using operators. So here we have a constant on the right-hand side. That exact value is stored in price per item. Here, number bought on the right-hand side, we would look up what's the current value of that property, and then whatever that value is, we would store it in number returned. So we would copy that. It's basically, after this, those two properties would have the same value. And then on the right here we have this is a calculation. I'll talk about what the asterisk means in a second, and we store that result. So we work out the result of this and then we store the result in total cost. Okay, now what are the operators and calculations that you could do on the right hand side of an assignment statement? Okay, well, we have special symbols that are used for the arithmetic operations that we can do in Java. And the symbols actually have different meaning potentially based on the data type to which they are applied. So if you are working with two integer data, okay, there are 5 operators that can be used. And when the two pieces of data that you're working with are integers, the result is always an integer, which is slightly different than maybe your experience in a math class. So let's take a look at this. Plus, as you might expect with integers, means addition. So we're going to add the two numbers together. Minus means subtraction. The asterisk is the symbol used for multiplication. If you've ever done anything with spreadsheets like Microsoft Excel, you know that the asterisk is the multiplication symbol. And then now for division, this is where it gets tricky. It gets a little different than maybe in your mathematical experience. The slash means integer division. If I have two integers and divided one into another, okay, the result has to be an integer. So that's a little different than you may be experienced with in regular math. If you say 5/2 or 5 divided by 2, you'd be expecting the answer to be 2.5, right? But 2.5 is not an integer. So integer division, slightly different. We'll talk about that in examples here coming up. And then there's also a percent sign. The percent sign does not mean percentage. Okay, the percent sign is the operator that means the remainder of an integer division. Let's take a look at some examples here. So if I have 3 integer variables, x, y, and z declared here, if I store 47 in x and 5 in y, now I have a bunch of assignment statements, and in the comments over here I'm saying what the answer would be in z. So x plus y, 47 plus 5, 52 would be stored in z. Here, 5 minus 47, z would get the value negative 42, because negative 42 is the value of the right-hand side. Okay, 3 times y, multiplication, or the asterisk means multiplication. So 3 times 5 is 15. That would be what's stored in z. Now here we go. 47 divided by 5. Okay, well that doesn't go evenly, does it? It would go 9 times, and it'd be like 9 2/5 or 9.4. Well, but because x and y are both integers, the result has to be an integer. I can't have that 0.4. So what happens is 47 divided by 5 is 9, and there's a little bit left over, and I throw away the leftover. I don't care. I'm not considering it. I only am looking at the integer quotient of this division problem. So 47/5 is 9. And then that's where this percent comes in. If you want to know what was left over, x percent y means take the value of x, 47, divide by the value of y, but then ignore what the answer is and just keep the remainder. So 47 divided by 5 is 9 with 2 left over. So I throw away the quotient and I just keep the remainder as the result of that expression. Okay, it takes a little bit of getting used to, but we'll see how that will work. Okay, for the double data type, there is no remainder operation. There's only 4 operators, and slash means regular division or real division. So it's the kind you're probably familiar with from mathematics. The result will have a decimal part. Okay, and so if the data that you're being operated on are doubles, the result is always a double. And you can mix integers and doubles in an expression. The integers are converted or promoted to a double, and then the result is a double. So as long as one of the operands, the values being operated on, is a double, the result of an expression is a double. Okay, so here I have 3 doubles, d, dd, and answer, and integer id. Okay, so as you might expect here, 4.5 plus 2.2 is 6.7. 6.5 minus 4.5, it's not just 2, it's 2.0. Okay, so the result has to be a double, which has to have a digit to the right. It could be 0 of the decimal point. D minus 3 would be 1.5. So notice I'm subtracting an integer, but it's converted to 3.0, and then it would give you 1.5. Now, D times 2, 4.5 times 2 would be 9, but it has to be 9.0. Okay. Now, ID divided by 5, okay, would be 47 slash 5, but that's an integer divided by integer, so there is no 0.4 part here. It's just the quotient, the integer quotient. But DD 47.0 divided by 5.0, that's a double divided by a double, and so I actually do the division. It's 9 and 2/5 or 9.4. And then if I have a double divided by an integer, it also gives me the result as a double. Okay. Now, one last thing to talk about, and then the next video will show an example here. So, how can we print text in the Java console? Well, in the output window, you can use g.drawstring to print text, but that's kind of a pain because you have to specify the over and the down, and it's really hard to get things lined up and so on. So there's a more convenient output window to use in our Java programs. It's called the Java console, and NetBeans labels it as the output window. So when you run the program, the output window is displayed at the bottom of the NetBeans environment. You can actually send output to the output window using these 2 commands, system.out.println, okay, then inside parentheses is whatever is going to be printed. And the ln means after what's being printed, we move, the next thing to be printed will be on the next line. So this is like pressing enter on the word processor to move to the beginning of the next line. Okay, whereas system.out.print will print something, whatever is in between the parentheses, and then the next thing to be printed will be on the same line in the output console. Okay, so the Java console. So I'd like to end this video now, and then the next video will be a demo of a program that uses these concepts.